previous session recordings, or if you haven't joined live. And today we will discuss few concepts related to this complements. And after completing these concepts, we can explore more problems. I thought of having problem session today, but on number systems we have I have less problems. So if we discuss this complements, then I can discuss more and more problems, right? Yeah. So first let's discuss about this complements and ranges of numbers and all, and then we will move forward, right? Now, yeah. So let me share my screen. Second. I hope my screen is also visible, right? Can anyone please let me know in the chat box? Yeah, thanks for letting me know. Now, coming to this particular complements, we have different kind of complements. So we have basically R's complement and R minus 1's complement, right? Where R basically stands for base of a particular number. So R is nothing but my base of a number. For example, if my R is equal to 2, then I'm going to have basically 1's complement and 2's complement. And let's say if my R is equal to 8, we are going to have 7's complement and 8's complement. And let's say if R is equal to 10, which is nothing but my decimal, I'm going to have 9's complement and 10's complement. And if my R is equal to 16, then I'm going to have 15's complement and 16's complement. Okay, so these are the different complements which I'm going to have in my number systems, right? Yes. Now, anyone can tell me, like, why are we using this complements? Like, why are we learning this one's complement and two's complement? If you already know, can anyone answer? What is the reason of learning this complements, or why are we using this one's complement, two's complement, and all seven's complement, eight's complement? Any answers for this? Okay, for subtraction. Any other answers? Okay. So basically, as Ankit said, we can also use it for subtractions as well as, let's say, if I want to store any negative number in my hardware, basically, I'm going to convert that into this particular complemented form and I'm going to store. In the case of my binary, I'm going to use ones and twos complement, right? Now, let us try to understand. I know everyone knows about this ones and twos complement, but let's once revise them. So let's say if I'm going to have my base two number, then I'm going to have a number like this 1011. Then if I want to find out one's complement of this particular binary number, it is nothing but 0100, right? And if I want to find out two's complement to this, then I'm going to just add plus 1 to this so that it will become 0101. This is nothing but my one's complement and two's complement. Now, let's say if I have this number 1011, and if I directly want to perform two's complement on this without actually converting it into one's complement and adding plus one, what I can do is, see, I can move from right hand side to left hand side, and I'm going to copy one as it is. And if I've encountered one, and from next bit onwards, I should perform the complement. So this is nothing but my zero, this is one, this is zero. So this is how we are going to, directly perform two's complement. For example, if I'm going to have 0, 1 second, give me 1 second. If I have this value 0, 1, 0, 0, 0. Now, how to perform two's complement on this particular value? So I'm going to move from right hand side to left hand side. So 0, if I've encountered, I'm going to write it down as it is. Now I have encountered 1. So this 1 will be written as it is. And from this next bit, I should perform the complement, which is nothing but this. So this is how we are going to perform two's complement directly. Is it clear, guys? Anyone having any queries in this two's complement? Shall we move forward? Okay. Now, I'm coming to my sevens and eights complement. So it is also very easy thing. So what we can do in the case of my sevens and eights complement. So let's say suppose if I have any particular number 2, 3, 4, base 8, and if I want to perform sevens complement on this number, then I'm going to subtract each particular digit by 7, which is nothing but 7 minus 4 is 3, and 7 minus 3 is 4, and 5. So 543 to the base 8. And if I want to find out 8's complement, I'm just going to add plus 1. So that is, it is nothing but 544 to the base 8. And 15's and 16's complement, 9's and 8's complement, all will be the same manner. This is what we are going to follow. Okay. Now, let's say if I'm going to have my binary numbers. So let's talk about this particular numbers. Let's say if I'm going to have my binary numbers which are present. And this binary numbers can be classified into two types. One is unsigned representation and another is signed representation. Anyone wants to answer what do you mean by unsigned and what do you mean by signed? What is the difference between unsigned representation and what do you mean by signed representation? Yeah. So basically, in the case of your signed number, you're going to you can represent basically both positive and negative numbers, right? In the case of your unsigned numbers, you can only represent positive numbers. Okay. So this is the difference between your unsigned numbers and signed numbers. Now, for example, if I'm going to consider a unsigned representation, if I'm going to consider a unsigned representation, okay, and I'm going to basically allocate, four number of bits. Now, what is this? Let's say suppose if I have plus zero, it can be represented as 0000 plus one. It can be represented as 0001. So on up to where we can represent up to plus 15 we can represent, which is nothing but 111. Is it clear, guys? And let's say if n is equal to 5, we can represent it up to 0 to 2 power n minus 1. Okay. So, sorry, 2 power minus 1 will be dot. So, 2 power n minus 1. Okay. So, for a n bit number, for a n bit unsigned representation, we can basically represent the values from 0 to 2 power n minus 1. This is the range of numbers which we can represent. Okay. Now, let's say if I am going to use signed representation. In the case of my signed representation, I can represent both positive numbers as well as negative numbers, right? So for this kind of representation, I have different kind of methods. One is sign magnitude representation, sign and magnitude representation, and in short form, I'm going to call it as SMG. And the second one is one's complement format of representation and two's complement format of representation. So these are the different kind of representations I do have for representing a signed value. Okay. Now let's talk about first type of representation, which is sign magnitude format of representation, SMG. So in the case of my sign magnitude representation, I'm allocating a extra bit for representing my sign. Let's say if I want to represent plus sign, I'm going to use 0 for it. And if I want to represent minus sign, I'm going to use 1 for it. For example, if I have plus 5, I'm going to write it down 0, 1, 0, 1. So for representing my sign, I'm allocating a separate extra bit. And for representing minus 5, I'm going to write down as 1, 1, 0, 1. So this is nothing but my plus 5 and minus 5. Now let's say if I'm representing the numbers in SMG format and if I've allocated n is equal to 3 bits. Can anyone tell me what is the range of numbers which we can represent over here? You can take your time and can anyone tell me if I'm representing my numbers in SMG format and if I've allocated only 3 bits, then what is the range of numbers which I can allocate over here? Waiting for your responses. Okay, I got one answer. minus 7 to plus 7. Okay. So these are all you can expect in your interview written test also. These are, simple questions which can be given in your MCQs and all. So you need to be careful over with this minus 3 to plus 3. Okay. I got three answers. What about others? So if I'm representing the numbers in SMG format and I'm going to have only three number of bits, then what is the range of numbers which I can represent? Okay. Let's see what is the range of numbers which we can represent. Let's say suppose if I'm going to have plus 0. Let's say if I'm going to have plus 0, then how to represent this? It is nothing but 0, 0, 0. This is used to represent your plus sign. Okay. Then can I represent minus 0? Yes, you can represent. How you're going to represent 1 followed by 0, 0. This is nothing but my minus 0. Okay, fine. Next, plus 1. Plus 1 is represented as 0, 0, 1. And minus 1 is represented as 1, 0, 1. Okay. And plus 2. Plus 2 is nothing but 0, 1, 0. And minus 2 is nothing but 1, 1, 0. Okay. And plus 3, which is nothing but 0, 1. And minus 3 is nothing but 1, 1, 1. That's it. Now, if I want to represent plus 4, it is nothing but 1, 0, 0. Can I represent this plus 4, 1, 0, 0? Is there any value which is taking this code already, 1, 0, 0? Exactly. This is already taken, right? This code is already taken. How can you allocate plus 4 to 1, 0, 0? No, this is out of range. Okay. Now let's say if I suppose if I want to represent minus 4 is nothing but it should be written as 1, 1, 0, 0. You are going to take 1, 2, 3, 4 bits, but you are going to have only 3 bits, right? This is also out of range. So what is the range of numbers which you can represent is from minus 3 to plus 3, including minus 0 and plus 0. This is a range of numbers which you can represent when you are going to have n is equal to 3 in the case of SMG format. Is it clear for everyone? Yes, yes, we are coming to that particular point. First of all, the range calculation, is it clear? Yeah. Now, if you carefully observe in the case of your SMG format, we have two representations for 0, which is plus 0, we have one value, and for minus 0, we have one value. But if you are going to add plus or minus to a 0, it's not correct, right? It's not logically correct. Okay. So this is the disadvantage we are going to have in the SMG format is that we have two representations for 0. Okay. Yeah. Is it clear for about the SMG format? Shall we move forward? Okay. Now, let's say suppose if I have n is equal to 4 number of bits. Now, can anyone tell me the range of values which we can represent when n is equal to 4? Waiting for your responses. If n is equal to 4, what is the range of numbers which we can represent in SMG format of representation? Sign magnitude format of representation. Minus 7 to plus 7. Okay. I got one response. Minus 7 to plus 7. Yes. So basically, if my n is equal to 4, then the range of numbers which I can represent is from minus 7 to plus 7. Exactly. Right. So if you want, you can write it down. If in your exam, if you want to have it a quick check, you can write down this particular values. So plus 0, plus 1, plus 2, plus 3, and plus 4, which is nothing but 0, 1, 0, 0. This is nothing but 0, 1, 0, 0, 1, 1. This is 0, 0, 1, 0. This is 0, 0, 0, 1. And this is 0, 0, 0, 0. And minus 0 is nothing but 1, 0, and minus 1 is nothing but 1, 0, 1, and minus 2 is 1, 0, 1, 0, and minus 3 is 1, 0, 1, 1, and minus 4 is basically 1, 1, 0, 0. That's it. Okay. If you want to represent plus 5, then it is you're going to have is 0, 1, 0, 1. You're going to have plus 5 also. Okay. And minus 5 is 1, 1, 0, 1. Okay. and plus 6 is basically 0, 1, 1, 0, and you can also represent plus 7, which is 0, 1, 1, 1. Okay, and you cannot represent plus 8. Plus 8 will be out of range. Okay, so from minus 7 to plus 7, you can have the range. Okay, yes. Now, for generalized equation, let's say, suppose if we have a n-bit number, then what is the range of numbers which we can represent in SMG format? So in the case of normal format, in the case of unsigned numbers, we have seen for a n-bit number, we have the ranges from 0 to 2 power n minus 1, right? So what is the range over here in the case of my n-bit numbers, in the case of my SMG format? Take your time and let me know. Exactly. So over here, if we carefully, yes, minus 2 power n minus 1 minus 1 2 plus 2 power n minus 1 minus 1. Exactly. So over here, if we carefully observe, if n is equal to 4, and if we consider it as 2 power n minus 1, it is 2 power 4 is 16 minus 1, 15. But we are having only 7, right? So there should be minus sign in your exponent also. So the range of numbers which we can represent is minus 2 power n minus 1 minus 1 2 plus 2 power n minus 1 minus 1, including plus 0 and minus 0. So this is a range of numbers which we can represent using SMG format of representation. Is it clear, guys? Any doubts over here? Shall we move forward? Yes. Now, coming to next format of representation, we have 1's complement format of representation. So in the case of my 1's complement format of representation, let's say my positive numbers are represented in their original form and negative numbers are represented in their 1's complement form. Okay. Now, what do I mean by this? Let's say suppose if n is equal to 3. Let's say if my n is equal to 3, then plus 0 is represented as 0, 0, 0, and plus 1 is represented as 0, 0, 1, and plus 2 is represented as 0, 1, 0, and plus 3 is represented as 0, 1, 1, and minus 0 is represented as 1's complement of this plus 0, which is nothing but 1, 1, 1, and minus 1 is nothing but 1, 1, 0, and minus 2 is nothing but 1, 0, 1, and minus 3 is nothing but 1, 0, 0. And nowhere here I'm allocating a extra bit for representing my sign. I'm just representing my negative numbers in the complemented form. That's it. And if you carefully see, when I'm representing my negative numbers in 1's complemented form, automatically my MSB is 1. Can you see over here? So if I'm representing my negative numbers in 1's complemented form, my MSB is equal to 1. That means this is my negative number. That means if you have got any particular question like this, let's say if any number is represented in its 1's complement form, give the value of that particular number. Let's say if a particular number 110 is represented in 1's complemented form, then what is its value? If you got a question, then is it minus 6 or plus 6? What is the answer, guys? Obviously, it's not minus 6, it's minus 1. Okay. So if we have seen any particular number as which MSB is equal to 1, then you should come to a conclusion that it's a negative number. And 110, what is its value here? Minus 1. Okay. So how to get it? How to get this value? Again, perform 2's complement on it. It is nothing but 0, 0, 1. And since MSB was 1, you can simply write it down as minus 1. Is it clear? Yeah. Now, let's say suppose, okay, let's say plus 4. If we have plus 4, it is nothing but 100. This will be out of range. Why it is out of range? Because your MSB is becoming 1 now. For positive numbers, you can see MSB is 0 only. Okay. So you can treat this plus 4 as out of range. And let's say suppose if you have minus 4. Minus 4 is nothing but plus 4 is 100 and minus 4 is 0. 1 1 complemented form, but 0 1 1 is already taken, so this is also out of range. You cannot have -4 and +4. Again, the range of this one's complemented format if n is equal to 3 is from -3 to +3, and again you have two representations for 0, including +0 and -0. So this is a range of numbers which you can represent for n is equal to 3, that is from -3 to +3. And let's say suppose if n is equal to 4, again the range of numbers you can represent is range is basically from -7 to +7. So let's say suppose for n, then it is nothing but -2 power n minus 1 minus 1 to plus 2 power n minus 1 minus 1, including +0 and -0. Is it clear, guys? Any doubts or any queries over here? Okay, great. I hope it is clear. Now let's move forward and let's see last complemented format of representation, which is 2's complement format of representation. So in my 2's complement format of representation, again the same thing. Original number is represented in normal form. Okay, so your positive number is represented in original form, whereas negative number is represented in 2's complement form. Okay. For example, if I'm going to have n is equal to 3, then what is the range of numbers which can have +0 is 0 0 0, +1 is 0 0 1, and +2 is 0 1 0, and +3 is 0 1 1, and -0. If you perform 2's complement on this, there is no 1, right? So it will be 0 only. And -1, it is 1 1 1. I'm representing this in 2's complement format. And -2 is 2's complement of this, which is nothing but 0 1 1, and -3 is 1 0 1. Okay, and let's say suppose if you want to write down +4, +4 is nothing but 1 0 0. Okay, now coming to my -4, -4 is nothing but it is 2's complement of this, which is nothing but 1 0 0. So you cannot consider +4 since your MSB is equal to 1. This is will be out of range, but this is valid. Okay, because your MSB is equal to 1. So what is the 2's complement format of range? Range is here -4 to +3. And you have only one representation of for 0. Okay, so this is the disadvantage over this is advantage over ones and sign magneted format, where you can have only one representations for 0. Okay, and the range is from -4 to +3. And for n bit representation, you have the range from -2 power n minus 1 -1 to +2 power n minus 1. This is the range of representations you have in the case of your 2's complement format of representation. Is it clear, guys? Okay, okay. Yeah. Okay. Yeah. So this was about representing your negative numbers in sign magnitude format of representation, one's complement and two's complement format of representation. So as we have discussed at this particular things, now we can explore more problems related to this particular concepts. So in our next session, we are going to discuss problems related to this particular sessions, right? Yes. So if you have any doubts or any other queries you wanted to discuss with me, you can stay and discuss with me, or else we can wrap up this session. Okay. Thank you. Have a great day.